right, Math 8, we're going to go over 5-1, the systems practice. I'm going to go over numbers 1, 2, and 3, just because the way they're worded, they sort of are ambiguous, especially number 1. When I first started to work this out, it was like, okay, what are they asking us for with these questions? I don't know what they want me to write in those blank spaces. 2 and 3 will make more sense once you see what you're supposed to do with number 1 to make it easier. First things first, in this one, what conclusion can you make about the systems of equations here, these two equations? What you're looking for with systems of equations is where do they cross? Or do they cross? How many times will they cross? Now, we talked about this earlier in the year. If you have the same slope in a problem, it depends on what the y-intercept is. If it's different y-intercepts, that means they're never going to cross each other. It means they're parallel if they have the same slope. If they don't have the same slope, that means they're going to cross one time. That's it. They crisscross each other. Now, if they have the same slope and the same y-intercept, those numbers there, y equals mx plus b, both of them, then they're the exact same line, and they cross infinitely a number of times. Okay, so the question that they're asking in this first one is pretty simple. The slope of the first equation is blank to the slope of the second equation. Are they the same? Are they not the same? Are they different? Are they whatever? That's all they're asking. Okay, the y-intercept of the first equation, is it the same or is it different than the y-intercept of the second equation? And then the system of equation has blank solutions. Well, how do you know how many solutions? Well, we just talked about it. If they have different slopes, y equals mx plus b, if they have different m values in both of them, automatically you know that they've got one solution. If they have the same slopes but different y-intercepts, that means they're parallel. They have zero crossings. They have zero solutions. Now, if they have the same slope and the same y-intercept, they're the exact same lines. They have an infinite amount of interceptions or intersections. Now, how do we know this? How do we work it out? We can't work it out with them written like this. These aren't written in slope-intercept form. We have to isolate the y values in these. How do I do that? Here you are. In the first one, I divide both sides by 6. 6y divided by 6 makes just y. 12x divided by 6 makes 2x. 36 divided by 6 makes 6. Y equals mx plus b. Y equals 2x. 2 is the slope, 2 over 1, it doesn't matter. Up 2 over 1, up 2 over 1, plus 6. This is where it crosses the y-axis at positive 6. So on your graph, it'd be up at 6 and then up 2 over 1, up 2 over 1, up 2 over 1. So it's a positive slope. All right? You got to know these things. Those are the basics that we should just know about graphing. Now, on the bottom one, how do I isolate this? Wow, it's so neat. Everything's just so conveniently divisible by 15. Divide this by 15, it just isolates the y. 45 divided by 15 is 3. 60 divided by 15 is 4. So now we've got both of our equations written in y equals mx plus b. I can't say it enough. Y equals mx plus b. That's slope-intercept form. This is the slope. This is the y-intercept. Okay? So when I look at this and they ask us our first question, the slope of the first equation, is the slope of the first equation the same or different than the slope of the second? That's a 2. That's a 3. They're different from each other. Automatically, I can already make the assumption, since I have different slopes, I have one intersection of these two lines. I don't even need to do anything with these problems. I know this because I've been told this. Okay, the y-intercept of the first equation is like or different from the y-intercept of the second. My y-intercept of the first one is 6. The y-intercept of the second one is 4. Are they the same or different? Pretty simple. They cross at different spots on the y-axis. They are different. Now, the system of equation has, I don't know, solutions. Being that they have different slopes, they have one solution, period. That's it, one solution. Now, number 2, how many solutions does this system have? The top one is written in slope-intercept form, nice. Y equals 3x plus 14. Y equals 3x plus 14 is in y equals mx plus b form. Now, the second one you have to divide by 4. Dividing both sides by 4, that cancels out. I'm left with just y. And then 12 divided by 4, okay, let me just plot my marker board here. I have 4y is equal to 12x plus 64. Divide everything by 4, that makes just plain old y. Divide this by a 4, that makes 3x. Divide this by a 4, 64 divided by 4, that is 16. All right. So my form for that one, y equals 3x plus 16. That's y equals 3x plus 16. That's y equals 3x plus 4. How many solutions does this have? They have the same slope. So automatically I've got to look at the y-intercept. Is the y-intercept the same? This one's 16. This one's 14. Same slope, different y-intercept. That means if I was graphing these, they're going to look something like that. They're both positive. They both travel. They don't intersect. So how many solutions does this system have? None. 0. No solutions at all because they have the same slope, but not the same y-intercept. Now, how many solutions does this system have? Well, it's really not written in slope-intercept form at all, not even close. So let me get this, my dry erase board ready to go. Y is equal to 4x plus 5. That one's done. Oopsie, too far down, silly me. There we go. X is equal to 3y plus, wow. X plus 3y equals 0, and 9y is equal to negative 3x. All right. I have to isolate the y value. This one, I have to bring the 7 over to the other side, so it's 7y is equal to negative x plus 0. Doesn't matter. Let's just put it there. Then I have to divide by 7. Y is equal to negative 1/7 x plus nothing. So it doesn't matter. Divide both sides here by 9. Y is equal to negative 3/9. But 3/9 is going to reduce. They're both divisible by 3. Should turn into negative 1/3 x. All right. The question says, how many solutions does this one have? Well, the good news is there's only one solution. And how do I know? Different slopes. This is a negative 1/7. This is a negative 1/3. They're both negative. Great. They both go down, but they're not the same. This tells me they both cross the y-axis because they're both plus 0. That means they both cross the y-axis at 0, the origin. That's the only place that they cross. They cross both there. This one goes down 1, right 7, down 1, right 7. This one goes down 1, right 3, down 1, right 3. And they just make two different lines that both cross at 0. Okay? You just need to know that the problems have to be set up into slope-intercept form. Okay? Y equals mx plus b. Set them up like that. Work on the rest of them. Look at the problems. See if you can answer them. Like, the rest of them are pretty simple. You just have to convert them and use what I've just told you about numbers 1, 2, and 3. I'll go over the rest of the worksheet tomorrow. Use what I've done for numbers 1, 2, and 3 to help you out. I'm sorry, I'm videotaping my desk as opposed to anything, just my voice. And we will look at this later. I'll talk to you. Have a good night. Bye.